Okay, today class we will discuss some problems based on the subspace. Okay, first we will do this problem. Prove that the subset, okay, the subset, this one W is ordered triples x2 s3 belong to R cube, no? Here this condition x1 plus s2 plus s3 equal to 0. Okay, of the vector space B3 real number, okay, B3 real number is a subspace of B3 real number. This B3 real number means ordered triples. B4 real number means x1, x2, s3, s4. Okay, right. It is the subspace. They asked to prove it is the subspace. So you want to check three things. First one is this set is non-empty. Then you take two vectors like x1, s2, s3, y1, y2, y3. Then addition also belong to this one. Second condition. Third condition is scalar multiplication of that vector. That means you take one of the scalar alpha belong to real number. Then alpha time this x1, s2, s3. Right? That one also, if that one is belong to W, then we can say that W is a subspace. Therefore, we want to check three conditions. For a vector space, you want to check the 10 conditions. Here, there are three conditions. The two conditions, the addition and scalar multiplication, we can consider one for one condition, right? That be from this example you will understand, right? Okay, right. First thing is this one, order triples, no, 0, 0, 0 belong to W. Okay, this one should satisfying this condition, 0 plus 0 plus 0 equals 0. Because, okay, so this set W is non-empty. Set W is non-empty. Let you take vectors x equal to x1, x2, x3 is one of the vector belong to W. Similarly, y equal y1, y2, y3. This both are belong to W. So these two vectors are belong to W mean this one satisfying this condition. That is x1 plus x2 plus s3 equal to 0 and y1 plus y2 plus y3 equal to 0. Now your claim is you want to show that x plus y also belong to W. So x plus y. X is x1, x2, x3, y1, y2, y3. So it is x1 plus y1, x2 plus y2, x3 plus y3. Now your claim is you want to show that this addition also equal to 0. Check that one. That means x1 plus y1, s2 plus y2, s3 plus y3. You can arrange the order x1 plus s2 plus s3, y1 plus y2 plus y3. It is 0. That one also 0. Therefore, altogether 0. Therefore, this one satisfying the that condition. Therefore, this element belong to W. This element belong to W. Okay. This element belong to W. Okay. This condition okay. Next, scalar multiplication. For a scalar multiplication, you take let alpha belong to real number. You take x equal to x1, x2, x3 belong to W. So you want to check alpha x. So alpha x, right? Alpha x is a usual addition and scalar multiplication. Okay, here we use the usual addition. No, similarly here also usual multiplication, scalar multiplication. So this is your alpha x1, alpha y1, alpha x1, alpha x2, alpha x3, right? You want to show that this one belong to W. Therefore, this element, that means alpha x1, alpha x2, alpha x3, you can take outside alpha, then x1 plus s2 plus s3. Here x belong to W mean x1 plus s2 plus s3 equal to 0. So it is alpha times 0 again 0. Therefore this element satisfies that condition. Therefore this is belong to W. So these two conditions are satisfying and non-empty set also. Therefore W is a subspace. Is a subspace of B3 real number. So another method, so alternative method for this one. Okay, right. It is one of the method, but this is also another method, right? I will reprove this one for using the another method, right? You take, okay, you take let two scalar alpha beta belong to real number. Okay, alpha beta belong to real number, and two vectors x equal to x1, x2, x3, y equal y1, y2, y3, both are belong to doubles. Okay, both are belong to doubles. So your claim is you want to show that this one alpha x plus beta y belong to W. That is your claim. So alpha x beta y equal alpha times x is your x1, x2, x3 plus beta times y1, y2, y3. Here there's scalar multiplication and vector addition, both are usual, right? Then this one alpha x1, alpha x2, alpha x3, beta y1, beta y2, beta y3. So alpha x1, beta y1, alpha x2, beta y2, alpha x3, beta y3. Okay, alpha x3 and beta y3. What is your claim now? What is your claim now? You want to show that this one belongs to W. This alpha x plus beta y belongs to W, but this one equal to this one. Therefore, this one belongs to W. This one belongs to W mean this element satisfying this condition. Okay, that condition. So you want to check that suppose you add three elements, this element, this element, this element, you want to get 0. Let me check that part. Alpha x1 beta by 1. Okay, alpha x1 beta by 1, alpha x2 beta y2, alpha x3 beta y3. So we do the arrangement here. You take alpha outside, you get S1 plus S2 plus S3 and beta y1 plus y2 plus y3. You already know that x comma y belong to W. Therefore, x satisfy this condition. That means x1 plus x2 plus x3 0. Similarly for a y1 plus y2 plus y3 also 0. So this is your 0 value. This one also 0 value. Therefore you get 0. This one 0 means, right? This one 0 mean this element belong to W. This element belong to W. Okay, right? Suppose they asked to show that this subspace. One of the method is this one. First you show that non-empty set and this two condition. Or otherwise you can do like this. This is the common case. You want to show that this non-empty set is a common case. Then for the second and third part, we can do this method. Okay. For a one thing, we can do it, right? Like this. Therefore, this one belong to W. So non-empty set and also belong to W. Therefore, W is a subspace. Therefore, W is a subspace of B3 real number. W is a subspace of B3 real number. Is it okay? So, right now, okay, therefore you can get, so now you will, now you got the idea. Okay, next we will move another problem, right? That is also based on the subspace. Okay. Okay, next move to another problem. That one also subspace. Prove that the subset W here also triples S comma Y comma Z. Condition x minus 3y plus 4z equal to 0 of the vector space R cube. Of the vector space R cube is a subspace of R cube. So for this question, okay, for this question, I will use this method. Okay, I will use this method. That method also is correct, but for this moment, I will use this method. Okay, you can do this method, no problem, right? So first condition is you want to check the non-empty case, no? So obviously this 0, 0, 0 belong to W. Therefore it is obviously non-empty, no? So let alpha, beta belong to real number x. So okay, so x equal Otherwise, you will write like this. You can take like this. Let alpha equal, you can write s comma y comma z. So here you can put x1, y1, z1. Okay, x1, y1, z1. Similarly, beta x2, y2, z2. And you take scalars c1 comma c2 belong to real, two scalars. Okay, alpha comma beta belong to w, no? Alpha comma beta belong to w, and okay, alpha comma beta belong to w means satisfying this condition, right? Okay. Now c1 alpha, c2 beta. Now your claim is you want to show that this one belong to w, right? This one belong to w. So your alpha c1 is this, c1 into x1, y1, z1, c2 into x2, y2, z2. So you can write c1 x1 plus c2 x2. Coordinate wise you can add c1 y1 plus c2 y2, c1 z1 plus c2 z2. So okay. Now your claim is you want to show that C1 alpha plus C2 beta belong to W. Okay. That means this condition also should be satisfying there. This one okay, this one. For this condition, you want to show that this one minus 3 times this one plus 4 times this one equal to 0. That is your claim. Okay. So consider that one C1 x1, C2 x2 minus 3 times this one C1 y1, C2 y2 plus 4 times z is your this one C1 z1, C2 z2. So here alpha comma beta belong to W. Therefore, this both vectors satisfying this condition. That means x1 minus 3y1 plus 4z1 equal to 0, x2 minus 3y2 plus 4z equal to 4z2 equal to 0. So we can write this one is c1 x1 minus 3 c1 y1 plus 4 c1 z1. We can arrange, okay? c2 x2 minus 3 c2 y2 plus 4 c2 z2. So you can take common c1, this one x1 minus 3y1 plus 4z1 plus c2 x2 minus 3y2 plus 4z2. So it is c1 times 0, c2 times 0, therefore so altogether 0. Therefore 0 means this element belong to W. This element belong to W. Okay, this element belong to W. This element belong to W mean W is a subspace. Okay, W is a subspace. So W is a subspace of which one? Real. Okay, subspace of real cube. No, subspace of triple no or to the power cube. Okay, W is a subspace of R to the power cube. Next question. Prove that the subspace, right? Sorry, prove that the subset prove that the subset, right, the subset W is equal triple S comma Y comma set. The condition is S equal Y equal set is a subspace of B cube R. I already told you B cube R means each of the element in real number, B cube means triples. Okay. V2 means there are two elements. This Cartesian product, V2 real means. Okay. So the claim is you want to show that is the subspace. So first this one obviously 0, 0, 0 satisfying this condition, therefore belong to W, therefore it is non-empty. Right? It's non-empty. Next, we take let alpha comma beta, okay, alpha equal, you can write x1 y1 z1, x1 y1 z1, beta is x2 y2 z2, alpha comma beta belong to W. Okay, and C1 C2 in real number, C1 C2 in real number. So from this one we can C1 alpha, C2 beta. Now your claim is you want to show that this one belong to W. Okay, so about C2 beta. So C1 x1 y1 z1, C2 x2 y2 z2. So it is C1 x1, C2 x2, C1 y1, C2 y2, C1 z1, C2 z2. Okay. Now you want to show that this one equal to this one equal to this one. These three elements are equal. Okay. X1, Y1, Z1 equal S2, Y2, Z2 mean, sorry, S1, Y1, Z1 belong to W and S2, Y2, Z2 belong to W. Therefore, you have X1 equal X1, Y1, Z1, right? X1, Y1, Z1 and S2, Y2, Z2. So, C1, X1, C1, Y1, C2, Z1. C1, so C1 Z1, C2 X2, C2 Y2, C2 Z2. So, right, so we get this two, C1 X1 plus C2 X2. This one equal to C1 Y1 plus C2 Y2, right, equal. This one equal to C1 Z1 plus C2 Z2. Therefore, these three elements are equal. That means this one equal to this one equal to this one. Therefore, this one belong to W. This one belong to W. Therefore, W is a subspace, right? W is a subspace of V cube real number. Okay, subspace of V cube real number. So next problem. If a vector space, okay, is the set of real value continuous function, is the set of real valued continuous function over the field of real numbers. Over the field of real numbers. Over the field of real numbers. Then prove that the set W, the set W of solution of the differential equation of solution of the differential equation, this one, 2 d squared y over ds squared, 9 times dy over dx plus 2y equal to 0. Right? Differential equation, this one is a subspace of V. It's a subspace of V. Okay, it is the subspace of V. So, if a vector space is the set of all real value continuous functions over the field of real numbers, then prove that the set W is solution of the differential equation, this one. It's a second order, right, homogeneous differential equation. So you want to show that this one is a subspace of V. Okay, it's a subspace of V. You take W. First, you want to show that this is a non-empty set, right? First, you want to show that this set is non-empty set. So y equal to 0, y equal to 0 means this derivative 0, this derivative 0, y 0 means LHS side equal to RHS side. Therefore, y equal to 0 is the solution of this differential equation. Therefore, y equal to 0 belong to W. Y equal to 0 satisfies the given differential equation. So 0 belong to W is non-empty. Given set is non-empty. Okay, right. Next condition, let you take there as two solution S comma Y belong to W. S and Y are two solution. Okay. Sorry, not so Y1, Y2. Okay, Y1, Y2. We can't put because X there. Y1, Y2 belong to W means Y1 comma Y2 are solution of this differential equation, second order differential equation. So Y1, Y2 belong to W. Takes two scalar. So alpha comma beta belong to real. So you take like this t squared c1 y1 plus c2 y2 over ds squared minus 9 d c1 y1 plus c2 y2 over dx plus 2 times c1 y1 plus c2 y2. So this one we can write 2 d squared, c1 is a constant, no? Then you can write of this form is this one. 2 c1 d squared y1 over dx x1, sorry, x squared, right? Again 2 c2 d squared y2 dx squared. Here minus 9 c1 dy1 over dx minus 9 c2 dy2 over dx. Here 2 c1 y1 2 c2 y2. Okay, 2 c1 y1 2 c2 y2. So it is to write this 2 c1 d squared y1 over ds squared 9 c1 dy1 over dx 2 c1 y1. Similarly for c2 2 c2 d squared y2 over ds squared 9 c2 dy2 over dx plus 2 2 c2 y2. So you can take here c1 is common. You have 2 d squared y1 over ds squared 9 dy1 over dx 2 y1 plus c2 2 times d squared y2 over ds squared minus 9 dy2 over dx plus 2 y2. So y1, y2 are solution of this differential equation. Therefore, y1 satisfying this equation. Similarly, y2 also satisfying this equation. Therefore, this is 0 values. This is also 0 values. Then we will get 0. This one 0 means this is one of the root of the differential equation. That one means the C1 y1 plus C2 y2 belong to W. That means C1 y1, C2 y2 belong to W. Okay, C1 y1, C2 y2 belong to W. Therefore, W is a subspace. Therefore, it's a subspace. Okay, W is a subspace of V. W is a subspace of B. Okay. Next question. So next question. Let V3 of real numbers it's a notation, okay? It's a notation, okay? A comma B comma C. A, B, C belong to real number. So triples A, B, C. We have vector space over reals. Over real. You know, the previous example we did not buy like this one, no? Right? Both are same, okay? Okay, both are same, right? Don't need to worry, right? It's a notation, okay? Okay, be a vector space of a real number uh, so that so that is a subspace of V3 real number. Okay, you want to show that it is the subspace. Okay, this is a subspace. So first of all, you want to show that non-empty because here 0, you can take b equal to 0 and c equal to 0 because real numbers. Therefore, this one belongs to W, therefore non-empty. Let you take two elements x equal to c of the form 0, v1, c1. Similarly, y equal 0, v2, c2 belong to W. Okay, and C1, C2 belong to real. Both are scalars. So C1x, C2, sorry, C already C1, C2 there, you take alpha beta, right? So the claim is you want to show that alpha x plus beta y belong to W. So alpha x plus beta y, alpha times 0, b1, c1, beta times 0, b2, c2. Then you can write 0, alpha b1, alpha c1, 0, beta b2, beta c2. Just usual addition 0, comma, alpha b1, beta b2, alpha c1, beta c2. Okay, beta c2. Right here, suppose here, right, element here of the form 0 comma element, here one of the element, here another element, right, here 0 one of the element, another element, but this one also belong to real number, this one also belong to real number because b1 belong to real number, alpha belong to real number, therefore alpha b1 also belong to real number, plus beta b2 also belong to real number, therefore addition alpha b1 plus beta b2 also belong to real number, here also this one belong to real number, therefore this one belong to W. Okay, this one belong to W. What is the reason? Reason is very important here. What is the reason for that one? Because you can write because here write alpha comma beta belong to real and what else? This x comma y belong to real. So this alpha b1 beta b2 also belong to real, alpha c1 beta c2 also belong to real, therefore it is one of the element of this set, therefore W is a subspace of V3R, therefore W is a subspace of V3 real number. Okay, W is a subspace of V3 real number. Next question. Next question. let A comma B comma C be fixed element. A comma B comma C, okay, A comma B comma C be fixed elements. Be fixed elements of a field F. Of a field F. Of a field F. So that W is given set triple S comma Y comma set AX BY C set equal 0. Here S comma Y comma set belong to F. Right? S comma Y comma set belong to F. Is a subspace of V3F. Is a subspace of V3F. Here is field where there is real or complex, no problem. Here, but here is field is real number. Okay. First of all, put x equal to 0, y equal to 0, z equal to 0, then this condition should be satisfying. Therefore, this 0, comma 0, comma 0 belong to W, 0, comma 0, comma 0 belong to W, thereby is non-empty. Let you take two elements, right? So alpha comma beta belong to F. Alpha comma beta belong to F. This F. Here is your okay. Field is F. Okay, right. And you take U. It is x1, y1, z1. B is x2, y2, z2. This both belong to doubles. Both are belong to doubles. So now your claim is you take this one alpha U, beta B. Therefore, you write to show alpha U plus beta B belong to doubles. So it is alpha times U is x1, y1, z1. Beta times B is x2, y2, z2. It is alpha x1, beta x2, alpha y1, beta y2, alpha z1, beta z2. Now you want to show that A times this one plus B times this one plus C times this one equal to 0. Check that one. A times alpha x1 beta x2. B times alpha y1 beta y2. C times alpha z1 beta z2. Try to show this one equal to 0, right? So you can set you can multiply because scale alpha A. So you get take outside alpha, then you get A x1. Here take outside alpha, you get B y1 plus C z1. You take beta outside, then you get A x2. Here B y2. Here C z2. Here x1, y1, z1 belong to W, therefore satisfying ax1 plus by1 plus cz1 equal to 0. Therefore this is 0. Similarly, this is 0. This altogether 0. This 0 means, right, this condition should be satisfying. Suppose this condition is satisfying, therefore this element belong to W. Therefore, W is a subspace. Okay. Therefore, W is a subspace. Subspace. All is a subspace. Okay, this one is a subspace of V3F. All is a subspace of V3F. Okay. Next question. Next question. Which of the following sets of vectors, which of the following sets of vectors, here it is A1, A2, A3 and so on, AN belong to Rn, are subspace of Rn, are subspace of Rn. So first question, which of the following sets of vectors, this one, are subspace of Rn? For all x such that, for any values of x such that first value is positive, greater than equal to 0. So they ask to check whether this is subspace or not for this one. Okay. So you take your W is a subset of this set. So W1 is this one. X belong to Rn. Which condition? And A1 is greater than equal to 0. So take let x equal to A1, A2 and so on, AN. Similarly, y equal to B1, B2 and so on, Bn. Both are belong to W. Okay, both are belong to W. Therefore, where here is under this condition A1 belong to W means this satisfy this condition A1 greater than equal to 0 and B1 also greater than equal to 0. Let take two scalar alpha comma beta belong to real. Yes, field is real. We have this alpha x beta y, alpha a1 beta a2, sorry, beta b1, alpha a1 beta b1, alpha a2 beta b2 and so on, alpha an beta bn. Okay, alpha an beta bn. Right. This one you want to show that this one belong to W1, but this one not so not belong to W1 because check, you can put some numbers, right? Arbitrarily you take alpha is 1, you can take any number, alpha 1, beta is, because real numbers, no, you put -1 here, alpha is -1, beta is, you can put any numbers, no problem, -2, alpha beta, x, right? You put a1, sorry, a1 is a1, no, a1, you can put any numbers arbitrary, a1 is 3, b1 is 4. So you check whether this element greater than equal to 0 or not. If greater than equal to 0, because alpha beta real number, you can put any values. Suppose this value is greater than equal to 0, this one belong to W1. Suppose this one not equal to 0, sorry, this value is not this value is not greater than equal to 0. That means less than 0. That means this element does not belong to W. So check that one. Alpha A1, beta B1. So alpha is -1, A1 is 3, beta is -2, B1 is 4. So it is -3, -8, -11. So check this value is not greater than equal to 0. No? Greater than equal to 0. I mean less than 0. Therefore, our condition is not satisfying. This condition is not satisfying. Therefore, W1 is not a subspace. Okay. For arbitrary numbers, condition is not satisfying. Therefore, W1 is not a subspace. Okay. Therefore, W1 is not a subspace. Okay. W1 is not a subspace of Rn. Okay. W1 is not a subspace of Rn. Second part. So all values of x such that a1 plus 3a2, a1 plus 3a2 equal a3. Check whether this is subspace or not. So like this you can do it, like a first part. So you take W, it is W is, let you take W is x belong to Rn, and satisfying this condition a1 plus 3a2 equal a3. Let x equal a1, a2 and so on an, y equal b1, b2 and so on bn, both are belong to W. Okay, both are belong to W. So both are belong to W, where a1 plus 3a2 equal a3, b1 plus 3b2 equal b3. These two conditions are satisfying because this, both vectors are belong to W. Therefore, this condition should be satisfying. Okay. Therefore, you take let alpha comma beta belong to real number, s comma y belong to W. S comma y belong to W. So alpha x plus beta y, it is alpha a1, what is the form? Alpha times x1, x2 and so on xn, beta times y1, y2 and so on yn. So it is of the form alpha x1, beta y1, alpha x2, beta y2, alpha xn, beta yn. Okay. You asked, then you want to show that, suppose it is of the form, then you add this one 3 times this one, you get this term. Suppose this term, you add this one 3 times this one, you get this term, A3 terms. Like A3 here, one of the term there, no? That term. Okay, that means you take these two terms. That means you obviously you know that. What is the term you can get next? Alpha x3 beta y3 and so on, alpha xn plus beta yn. Okay, what is the term you can get next? It is, sorry, after this term you can get alpha x3 plus beta y3. So suppose you add this a1 plus 3a2, you get a3. Similarly b1 plus 3b2, then you get b3. Similarly for this one you can get, which term you can get? Alpha x3 plus beta y3 at this one plus 3 times this one. Okay, let's check that one. Check that one. For this part, can write here. Okay, alpha a1 beta b1 3 times alpha a2 beta b2. You want to get which one? Alpha times a3 plus beta times a3. That's the thing you want to get it. Okay, check that one. Alpha times a1 plus 3a2 beta times b1 plus 3b2. This alpha times a3, it is beta times a3. This is a third term. Therefore, here alpha times a3, alpha times x3. Really, here, just wait. Sorry, we make the mistake here. You want to write here a1, a1, a2, and so on an. Here b1, here b2 is bn. So it is a1, it is beta a2, it is a2, b2, a3, b3, and so on, an, bn. Okay, right. So this the third term is alpha a3, beta b3. Therefore, this condition satisfying, right? Therefore, W is a subspace. Therefore, this element, right, belong to W, because this third element is this one here, satisfying that condition. Therefore, W is a subspace of Rn. Right? It's a subspace of Rn. Okay. Next part, for this question, next part. for all x, right, for all x such that a1 sorry a2 equal a1 squared. Check whether it is subspace or not. Same idea again. Let W is the set x belong to Rn and a2 equal a1 squared. So let x equal a1, a2 and so on an, y equal b1, b2 and so on bn, both are belong to W. So this one satisfying this condition where a1, a2 equal a1 squared, b2 equal uh, uh, b, uh, b2 equal b1 squared. v2 equal b1 squared. So take let alpha comma beta belong to real, then s comma by belong to W, the set W. So you take alpha x plus beta y, alpha x plus beta y. So it is of the form alpha times a1, a2 and so on an, beta times b1, b2 and so on bn. So this is alpha a1 plus beta b1, alpha a2, beta b2 and so on, alpha an plus beta bn. So you want to show that this is the element of that set, means you want to show that here this is alpha a2, sorry, alpha a1 beta b1 squared equal this one, alpha a2 beta b2. Is it possible? No, it's not possible. Okay, by using the counter example, right? It is not possible because you take alpha 3 beta 4 real numbers, you can any values. A1 is 3, A2 is 9, B1 4, B2 16. Check that values. 3 into A1. 3 into 3, 9. Beta is 4 into 4, 14. They are about 25 squared. Is 160, sorry, 625. Put here. This one not equal. Here alpha A2. Alpha A2. 9, 3, 18 plus beta 4, B2. 16 plus 4, 64. I think this one is 2, 82. But this not equal. Therefore, this one not equal. Therefore, this is not an element of W. Therefore, W is not a subspace. Is not a subspace of Rn. Therefore, W is not a subspace of Rn. Okay. Okay. Right.